share the screen. Can you mute yourself?
Sir, yes, it is visible, sir.
Yes.
It is visible, sir.
Okay. Good. So as I told you, this session will be based on ANSYS Fluent tutorial. Okay, that how you can run ANSYS Fluent, so that I will uh, try to understand. Means I try to describe. So in this case, earlier class, I was just showing the glimpses of different steps only. Now, in this particular problem, we rigorously review all the steps. And if you can understand these things, then you will be able to run a simulation. And after that, I can give you a tutorial link, okay, and that you can follow in yourselves, and you will be become familiar with it. Now, for running this ANSYS Fluent, you need not know all these details of finite difference, finite volume, etc. These are not needed because that solver is already given in this software. Okay, but what you need to know, you need to know uh, the governing equation, what will be suitable for it. Okay, that is first thing. Then you need to create the geometry, and you need to define the boundary conditions. You need to mesh it, and you need to set up the solution. Means the algorithm, there are so many algorithms available for solving it, that we will see now. Now how to choose them, so we'll have little bit of discussion on them. And the problem that we will we're going to take here is analysis of 2D axisymmetric laminar pipe flow problem in ANSYS Fluent. So it will be a 2D problem, because 3D problem at the beginning you may not there will be problem. Your computer will be hanged, and it will be difficult to handle. So better first try with some 2D problem, or at least axisymmetric problem you can consider. Okay, so laminar pipe flow problem, again we will take, what do you mean by laminar? That is a very low flow rate. If Reynolds number is below 1800 or 2000, then it is considered as laminar. So we will consider a laminar flow in a pipe. Okay, and the problem statement is like this: it is a 20 millimeter diameter pipe, and its length is 100 millimeter, and the water is entering into it at a velocity of 0.005 meter per second. That means 0.5 millimeter per second, very slow flow rate. And you need to find the velocity profile, in the velocity variation in the pipe. Okay, so this is the objective of the case. Now, why I am not getting the pen pointer option? Then yes. So this is a very small pipe, and your initial velocity is given at 0.005 meter per second, and nothing is mentioned about the outlet boundary condition, and the length is 100 millimeter. Okay, so this is what the things are given. Now we will start doing it elaborately in ANSYS Fluent. So let us move it. As I told you, that if you open your ANSYS Fluent, it will open in a workbench, or workbench window will come here. This is the window that will be visible to you. Left hand side will be a lot of options in ANSYS that is available. One of them will be this fluid flow fluent. Now you see there is CFX is also there, polyflow is there for polymeric flow. So these are different. So earlier these were developed as different softwares, and then ANSYS has taken over them. Okay, and now under the umbrella of ANSYS you will get all these options. So one of them is Fluent, which is very much reputed for fluid flow applications. So this fluid flow button, if you press, then this window will appear. Okay, so this window what I was showing you in the last example, and it states all the consecutive steps that you need to perform. So fluid flow fluent box, and you have one option to change here, that is analysis type, whether it is 2D or 3D. So you can change the type of analysis as 2D or 3D as per your requirement. So you fix it here at the very beginning. You have to mention this analysis type, whether it is 2D or 3D. Then you come to this geometry button. You press this geometry button, then that CAD window will be open to you. Okay. Now this is the geometry options where you can create your geometry. Now after clicking geometry, this will appear. So you can choose the desired units from the unit section. So at the left top, you will see there is a unit options. So if you mention in the unit box, you can mention it that whether it is meter or millimeter or any foot or any other unit, whatever unit, the lot of options will be available. So you put in millimeter or meter, whatever you want, you just give it. Okay. Then you need to choose a plane. Okay, so fluid flow, there is in Cartesian coordinate, 3 planes are possible: xy, zx and yz. So on which plane you like to draw this, that you need to specify. So choose your desired plane to draw the geometry. So here, for example, they have taken xy plane. Xy plane, this first one that they have selected. That's why you will see that axis is x and y, it is shown here, and this is the direction. Now sketching section is here to construct the geometry. Now after selection of this thing, if you press the sketching button, then the next window will appear before you. So this is the sketching option. So sketch option, this window, this is when you have clicked active, you have activated it. So these options will come, whether you like to draw a line by 2 tangents, or a polyline, or polygon, or rectangle by 3 points. So there are so many drawing options will be available, you can get it. So for a 2D pipe, we have to draw a rectangle from the draw section, because a pipe is a cylindrical shape which is a 3D shape, but we are going to do a 2D simulation. So 2D simulation means you have to take a cross section along the center line, along any diameter, and that here we will take the cross section along xy plane, and we will try to means this 2D plane of cross sectional plane of a pipe is basically a rectangular, right? So you take a rectangle here, you press the rectangle button, and one rectangle will appear here, and then you can put this dimension button to define the dimension. That means you have to specify the length and breadth, or height, length and height, whatever you need to place it here. Okay, so that is done in this, that is shown in this next window. So if you click that rectangular part, then this kind of rectangle will appear before you. Okay, now you go to the dimension, and this is the declaration of the dimension part. The moment after creating the rectangle, you come to this dimension part. So dimension block will be here. So after creating this rectangle, you press this dimension block. Okay, and this you will get this option, this H2V1. So H2V1 stands H for the height, and height means this x direction length H, and V means vertical direction length. So we are defining here that 100 millimeter is the height. That means this one is basically 100 millimeter, and V1, that is this one, this particular part, that is we are considering 10 millimeter. Okay, I think 10 millimeter diameter was given in that problem. That is why it is given 10. Now this is the dimension declaration is done. Then you have to go to the this window, this concept window. Okay, so for generating the surface, we have to click to the concept window button. So this is just a rectangle, but we need to create a surface. We are working on a 2D surface, right? So we need to create a surface on this particular geometry. So next, you on the top, you will get an option called concept. Now in the under the concept option you will get surface from sketches. These options will be there. There are so many options: surface from edges, split edges, 3D curve. So here the surface from sketch option will be applicable. So you just click on the surface from sketch so that you will get a surface like this. Okay, so the moment you will click that, a surface will be created in this way, and you see that here uh, appear surface SK1, which is represented by the shaded area. So this is by default, some name will come. The moment you will create a surface, it will having some name. You can change the name according to your choice by renaming it. So this is showing surface SK1, and this surface body is created. Okay, now here at the bottom, the details view. In this details view, if you go, you will see that body is surface body, then how many faces are there, how many edges are there, how many vertices are there, surface area how much, thickness how much. So everything is given, and there is an option called fluid solid. So whether this surface will be considered as a solid material or a fluid material, that you need to define here. So in this example, we are just considering only on the liquid body. We are not worried about the thickness of the wall, etc. So we'll change it. By default, it remains solid. We need to convert it to fluid. Okay, so there will be drop down menu here. It will come. So you have to convert it to fluid option. So this solid is need to be replaced by fluid. Okay, so you, that means the actually you are giving lot of actually setting up the problem gradually. Okay, you are trying to communicate with the ANSYS software and trying to convey the message that you are you wish to solve. So instead of solid, you now consider it as a fluid option. Then in the next step, so first click on the surface body to select the geometry. So you can click on it, you can select it, and then you can go to this mesh option. Okay, then by the way, after declaring this, you will automatically come back to this initial window. So initial window that we have seen. Okay, so far we are creating the geometry part. So geometry construction is over up to this point. The next step will be the mesh. So it will automatically lead you to these particular options, geometry options. After geometry, it will bring you to this meshing options. So meshing window will be opened. Then you select this rectangular surface that you have created in geometry, and you go here. There will be a meshing options will be available, and whenever you will click that meshing options, this generate mesh option you will get, and if you click it, the mesh will be automatically generated. So you see, if you do it, it will be meshed in this way. So mesh means what? In the finite difference method, what we are doing, if there was a rod or there was a fin like this, it was dividing the domain into a number of points, right? And this point we are trying to solve the differential equation in these particular points. Now these points are called mesh or grid. So you have to generate the mesh in this domain. So here once you do the generate mesh button, if you click, it will by default create the mesh in its own way. Okay, so for example, you see that this is done, but it is actually very crude mesh. Crude means the distance between the node points are very high. So we need to refine it. Okay, so refine this particular, this will not give you a very good results. Okay, so we need to refine it. So right click on the mesh and then click on the update mesh option to refine the mesh with new element size. So this is a 100 millimeter things, and right now by default it has taken how much? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it has taken 20 element. That means 100 means after 2 millimeter interval it has taken each point. Now this is considered as crude enough, so we need to refine it. Okay, so instead of this element size, so instead of 2 millimeter, you can reduce it, and in order to do it, you need to change the element size here. There will be option called element size in this details of mesh section. So you give it some lower value, and then you regenerate it, update it. Okay, there will be updating option in the mesh window. If you update it, it will be a refined mesh like this. Okay. After updating the element size, this is the mesh structure. So now this was crude structure, now this is a fine structure. Now select the edge you want to give the name by clicking here, and next right click and select the create name selection. So actually whenever you are arbitrarily creating the geometry, this edge has different names. Okay, now I can give a name to each of these edge in my own way. So what you will do for that? So in the top right hand corner, you will see that there is a create name section according to the edge. So you select the edge, okay, and next select the edge means if after clicking here, if you press the mouse here in this particular line here, then this line will be selected. Okay, then this line right click it and give a name called inlet. So I am defining the geometry, basically giving it a name. So this surface I am giving inlet, this surface I am giving a name outlet, and both these lines I am giving the name as wall. Okay, so this is my name. You can give any arbitrary name here. So inlet, outlet, wall, these are standard conventional nomenclature. So that we are giving here. So here, so after giving the names, the name will appear in this name selection part. So if you do it, you will see that all these names will be reflected here. Here. Okay, then so that is all about the meshing part. So meshing is done. Then the next stage, that was what? That was after meshing, you will automatically come to this setup options. Setup means you need to fix the governing equation. Okay, so that how to solve it, how to take the governing equation. So that will be shown here. So you go to the setup. This is the setup window, and you will first come to this general section. Okay, by default it will lead you to the general section, and this meshing, whatever you have done, whether it is a good quality mesh or bad quality mesh, that you can check. Okay, so this mesh check options are there. One can check the mesh quality by clicking this, but it is for this particular problem, since this is a very simplified problem, so meshing is not a problem here. You did not check it. But whenever some complicated geometry is there, let's say spiral channel is there, spiral geometry is there, some circular tank is there, so lot of the every time you will not get a very simple geometry. So in case of 3D complicated geometry, you need to check the mesh, that if there is any problem. Then you have to select the solver options. So solver options are generally two types. One is called pressure based solver, another one is density based solver. So this actually depends on how you are solving the Navier-Stokes equation. So generally we prefer pressure based solver, so that is default option and you can keep it there. Then whether it is steady state or transient means unsteady state. So whether it is DVDT term is there or not, that is the question that you have to define here. If you take a steady state, then automatically from the Navier-Stokes equation, that first term, that is rho del V del T term, will be 0, considered as 0. So it is we are solving here a steady state problem for simplicity. Then it is a steady state, we will select it. Then 2D space it can be planar, it can be axisymmetric, it can be axisymmetric fluid or different things. So we will consider it as a axisymmetric problem, because pipe flow can be considered as a axisymmetric condition. So if you take from the center to radius, and the other half of the radius will be showing same pattern. So one half if you calculate, then it is done. So we will consider axisymmetric space here. So one can click on this. There is a gravity checkbox button. So one can click on this to incorporate gravity in the problem. So if you like to incorporate the gravity part, then you can obviously use it. You have to click it, but you know that there are some of the problems, let's say capillary flow problem, etc., where gravitational force is not so useful. So you cannot, you may not consider that thing. So that is up to you, whether gravity you will keep it in this problem or not. So you can click it here because this is a millimeter level channel, gravity will work here. So this is all about setting up the general part. Okay, general part. Next come after general section, you will get a model section. Okay, so what will be the model equation? Now Navier-Stokes equation can be written in different forms. Okay, so those are known as different type of models. So what model you are considering, whether viscous laminar model, uh, if you let's say for example if you consider radiation heat transfer, then radiation model has to be incorporated. If you like to incorporate species transport model, then you need to incorporate it. If you like to solve multi-phase problem, you need to select that part. So a list of model equations are given here. Okay, so based on your situation you have to select some of them. So in this particular problem, this is a laminar problem where fluid is only flowing, only viscous force will be there. So it's a viscous laminar model that we are going to consider. So click on the viscosity model and choose viscous laminar from the drop down list. And you can choose turbulence model depending on your requirement. So if turbulence is there, then turbulence has to be declared here. But as you know, this problem in the very beginning it is told that it is a laminar flow problem, so there is no question of turbulence. So because turbulence model is another challenging task, separate model has to be considered. So those things are we are not bothered about it here. So we are just pressing this viscous laminar model. So that is the model declaration part. Then you see that general model, after that the option is called materials. So you need to now define the material property. So what material you will consider? So click on the fluid to edit material you want to use. Okay, so if you like to use any this plus sign, if you open it, there will be certain sub options will come. So you can give your own material property there, or you can use the material data from this database. Fluent has a database of different materials, so that you can select. So click on the Fluent database and it will open this box. So if you like to use the data property from the database, you just directly click it. This Fluent database material will appear before you, and you will see that so many materials are there. Okay, so 563 materials are there: acetyl chloride, acetane, alphabetically everything is given there. Now choose the material you want to use, and there is a collection of materials. In this case we have choose liquid, we have to choose liquid water from the list. So this is starting from A, alphabetically it is given. So from in the drop down list at the very end you will get water, liquid water. So liquid water you will get, and you have to declare this material type, whether it is fluid or solid, that you have to declare here. Okay, so in the Fluent database, so under fluid category you will get the liquid water, that you have to select. Okay, so that is the declaration of the material. The moment you are taking water, then water's property will be imported from the database, and if you like to change any database, that is also possible. So in this case now this fluid, you see you can check the material, the cell zone conditions, that you can check that whether water is taken here or not. So water liquid is added to the material list. So in this material list, in the fluid option, water liquid is now added. Okay, so that is taken in this particular problem after material declaration. Then you come to this cell zone conditions part. Okay, where you will get the surface body. So that we have, so click the surface body and this box will open. So if you click on this, in this cell zone conditions, if you click on the surface body option, so it will give you the material name. Now in the earlier part you just select the water liquid in the problem setup. Now you have to deploy the water in this domain, in this geometry, because there may be problem where water will be there, oil will be there, air will be there, so many materials will be there. Now which material is applicable at which domain, that you need to define. So for this simple case, this is not a problem because you have only one domain and one material that you are considering, but still you have to define in this cell zone conditions. you come this to the surface body, and in this material name you just select this water liquid options. Okay, and then press OK. Then after this cell zone declaration where you have mentioned the fluid geometry, then you come to the boundary condition part. So I told you that after setting the governing equation, you need to define the boundary conditions. So boundary conditions, the moment you will come here, it will show you different edges in this problem, and I have given different name for this each of these edge. So these we have given inlet, this is outlet, these are walls that we have already defined. So that you can see here, this inlet is there, outlet is there, pipe wall is there, interior surface body, that is what, so that is also given. So you when you click this inlet button, so there are so many options. So what type of inlet boundary condition you like to give, whether it is mass flow, whether it is pressure dependent, or many options are given, but we will choose this velocity inlet because we know the velocity at the left hand side, so that is given in the problem. So you just define this velocity inlet, this window will open, and you define 0.305 meter per second. Okay, so as you know, this is the value that is given in the problem that you define here. Okay, so inlet, you define this boundary condition. So click on velocity inlet and the box will appear. Put the velocity magnitude given in the problem and click OK. Then you go to the outlet. Okay, so this is the outlet part. Outlet means this right hand side part, and you give the pressure field. Okay, instead of value you just directly write pressure field, and select this pressure outlet for the outlet. Okay, so this pressure outlet, then next click on the pressure outlet and this box will appear, and here you put gauge pressure equal to 0 because you are not giving any pressure, it is just you have to define the gauge pressure 0. And this black flow direct, if there is any black flow boundary condition, that you can give it here, and in that case the direction of backflow will be normal to the boundary, so that is just mentioned. However, this is not so relevant in this particular problem. And you
So
can put
gauge pressure at which point is it talking about, sir?
what
Yeah, the
yes,
gauge pressure thing. At which point the gauge pressure is it talking
and
about?
at the very outlet, okay.
Okay.
So actually outlet boundary condition is not precisely mentioned in the problem. Okay,
Okay.
so we are going to give del p del x equal to 0. Okay, there as if the means if you realistically think that when fluid is flowing in a pipe and going out of it and going out in the normal atmosphere, so it's a free flowing condition. Okay, no more thing is there, no pressure is there. So that's why we are defining gauge pressure as 0. Okay, so that means there is no additional pressure, it is freely, it will move out from the tube. Okay, so that's why we are mentioning it 0. But if you see that, let's say you are like to eject the water inside a tank, inside a water filled tank, right? So then in that case this gauge pressure will be having some value,
Hmm.
okay, based on the water height in the tank, etc. So it will depend on the same. So it is a simple problem, we are assuming that it is normal, freely flowing outside the normal atmosphere, so that's why we are giving it 0. Clear? So
Yes, sir.
that, okay, so that you give here, then you click on OK. Then come to this solution part. So far I was setting up the problem, giving different boundary condition, defining the geometry, material property, everything we have done. Now we are coming to the solution part. Okay, this solution part means you are now fixing the solution algorithm. Solution algorithm means the moment I will the example that I have discussed in the last class was all about a temperature distribution problem. Okay, there is no big deal in it, but the moment you will solve Navier-Stokes equation, there is velocity and pressure both are there. So UVW 3 directional velocity will be there. If it is 2D, at least UV will be there and pressure will be there. Now this pressure and velocity are actually interacting parameters. Okay, so pressure field has effect on the velocity field. Again, velocity field is having any effect on the pressure. Means both are actually linked, coupled thing. So this pressure velocity coupling is an important parameter. Okay, so that is the most tricky part of the CFD solver. So that I will discuss later, but you know that this is a thing for this pressure velocity coupling, different varieties of algorithms available. Okay, so some of these algorithms are written here, like this simple, simplex, piezo. There is so many, means there's a big list is there. So we will try to cover this simple algorithm, at least one algorithm I will try to give you at the end. So this we have to select some algorithm. Now how to select them? I mean, which, how can you know that which is going to work better? Because each of this algorithm has certain advantages and disadvantages. Now that will come from your experience. Okay, the time you will spend on this area, the more insight you will get. Then you can select the proper algorithm. Okay, so that is again based on the, or you need to take help from literature, scientific literature. You can see that in the paper what kind of algorithm have used. You can take that part. So in this case, we will take this simple algorithm for pressure velocity coupling and you select it. Okay, in the solution method option, in this pressure velocity coupling part, you select the simple algorithm. Now this simple algorithm I will discuss at the end. Okay, not now, but for running ANSYS Fluent you need to define it. If you do not define it, then that by default value will be taken. Okay, so that is probably simple will be taken. Now next is that after defining this pressure velocity coupling scheme as simple, next part is spatial discretization thing part. Okay, spatial discretization means the that how you are discretizing the spatial terms of the governing equations. Okay, so there are again some algorithms are there. So some gradient like least square cells based, and if you keep press this drop down button, so many algorithms will be there, but you need not most of the time disturb it. You can take the by default values until and unless some special situation arises. So keep the gradient least square cell based, this method keep it as it is, or you can select it. Then the pressure term. Okay, so this is the spatial discretization, this gradient part, spatial part you can give it here. Then the space pressure part, you can take the second order, this second order for pressure discretization. So del p del x term that is available in the equation, so that you can use this second order. But there are so many methods, standard, presto, linear, so many methods are there, you can take any one. Select second order upwind for momentum discretization. So you see that there is step by step. First it is gradient, means gradient, this is declared, then pressure term is declared, then after that for the momentum equation you can take this second order upwind scheme. So these are different schemes. Second order upwind scheme is a very common scheme. Similarly, lot of other schemes are available, you to choose any one. Okay, again perfect selection of the scheme will come with the experience, so you need to select something here. Then after fixing this, that means all the discretization algorithm that you have defined here, uh, after doing this, you come to this one. This is called monitor sections. Okay, so monitor means after setting up the that thing, whenever solution will go, how can you monitor? Okay, that how many data you like to save, after how many interval you like to see the output, what graphical representation you like to see during the simulation. So that thing you can control from here. So in this monitor options, you can uh, uh, you can put all these things like print to console. So console means the bottom window basically. Okay, so this is the console. So print to console means whatever is going on, you everything in this console, so that you can take a track. Then plot, if you click this plot button means some parameters will be plotted. Okay, so iteration to plot, so how many iterations, after how many iterations it will plot, iterations to store, after how many iterations it will store, because it is whenever you will try to solve that matrix of linear set of algebraic equation, it is a solver, right? Now let's say you are working with Gauss Seidel, so it will iterative approach. So how many means thousands of iterations will go on. So how many data you like to save? Then now what are the equations? Continuity equations, x velocity equation, y velocity, because this is a 2D problem. So two component and continuity equation. These are the equations thing. So whether you like to monitor them, that means you like to see them, and check convergence. So whether your convergence criteria you like to see graphically or not. So you tick them. If you are not interested, you uncheck them. And what will be the convergence criteria that you can give? 0.001, 001, 10 to the power minus 6. So put convergence criteria as 10 to the power minus 6 for all. Okay, so this you have to put it based on your experiments, and it is shown that you have to put a very small value so that you can get a very accurate convergence. Okay, and after specifying all these things, you just give the OK button. So then after this monitor declaration, then final thing that will come before calculation is the initialization part. Initialization means you are considering matrix, right? A big matrix will be solved. Now you have to give some initial values to all the elements of the matrix, whether it is 0, 1 or any value you have to give. Now depending on the initialization of that values, your solution convergence time will depend. Okay, so you have to first initialize them. So how to say, this is here it is mentioned that you select the standard initialization method. There are so initialization methods are there, and compute from inlet. So you inlet boundary condition is given, so it is asked that you initialize based on the inlet boundary conditions, following a standard procedure. Then reference frame relative to cell zone, and then you put this say this initialize button, so that some initial value will be given to all the elements of that matrix of that solver. Okay, so that is the initialization part, and you see after that this calculation activities is coming, and under this run calculation button is there. So you can now run it. Go to run calculation, and then you can define the number of iterations, how much iteration you like to run. Okay, reporting interval is 1, means after each step it will report, and profile update interval 1. You can change it, put the number of as 1000. Okay, that you can give here, and then you finally you have to calculate it. The moment basically to solve that matrix Ax equal to b, that linear set of algebraic equation it is going to solve. Okay, based on the, now in nowhere you will see the Navier-Stokes equation in ANSYS Fluent, right? Because that equation is not revealed before you. But the moment you are setting up the problem here in this earlier step setup, in the setup section, whenever we are defining after this part, the steady state, unsteady state, somewhere we have defined it, right? So there actually automatically it is selecting that equation in its proper form. Okay, this viscous laminar part. So viscous laminar, the moment you are declaring, it is you are basically defining the equation here. Now, if you don't have knowledge about the Navier-Stokes equation, you cannot understand that what equation it is taking. Okay, obviously you can get the details of this thing from the Fluent manual. You can get the details of these viscous laminar equations, from where you can relate the Navier-Stokes equation. Okay, so this is here you put the calculate button, and then it will show that the simulation is going on with the help of this kind of plot. So this is with respect to iteration, these convergence plots are showing. Okay, so then once it is done, it will automatically stop, and then you can go to the result section for you show that once it is complete, you go to these results and then press graphics to plot the results. Actually you go to the contours, because contour diagram gives us lot of information. Contour, and this contour, the moment you will click the contour, it will give you that what you like to see, the node values, boundary values, global range, auto range. There's so many options are there. You select the suitable ones and then say save and display, if you put and then what parameter you like to see. This is here, it is velocity. You can also see the pressure. Okay, here no temperature equation is solved, so energy equation is solved, so temperature will not be there. So pressure and velocity mainly you will get. So these contours of velocity, then velocity magnitude. Okay, from this drop down list, and then if you save and display, you will get these kind of things. So it is showing you that this is an axisymmetric condition you have taken. Okay, so it is half of the domain is solved, and rest half of the thing you will get by mirror image of this domain. So to save time, we do not need to solve the entire domain, because this is axisymmetric geometry. So whatever will be at the top of this axis, horizontal axis at the center, the same will be reflected in the bottom. So you need not take the entire domain. You just solve this part, and then you can take the mirror image of it to get the entire profile. So you see this blue color is indicating zero velocity at the wall, and red color is maximum velocity at the center line. Okay, and similarly, if you like to see the pressure contour, you can get an idea like this from the contour. You just plot pressure. So you will see that high pressure is at the left hand side, and blue color indicates low pressure at the right hand side, so that fluid is flowing from left to right. Okay, then comes the post processing part. Okay, that how you can plot different, these are the contour diagrams to show the results at a glance. Then you can plot different. Okay, so you come to plot options, then data plots, xy plot, select xy plot is similar. You can see the node value position of x. If you know that any particular position, what will be the pressure or what will be the velocity, so that value you can take and you can plot them. For example, here plot direction is x, along x direction if they are plotting it, and node values and position of x-axis, that is shown here. So if you plot it, the position with respect to the velocity, okay, x velocity v, so that is shown, that how it is moving. So that kind of plotting is possible. Then other post processing is also possible. Go to create contour options in the upper channel. So if you go to this button, these things will come here. Then you can choose this periodic one shadow. So that's what I was telling, that this is half of the domain. So you can take full domain, choose the variable you want, the pressure or whatever you like to do, and then based on the your choosing conditions, you can get a distribution like this. Okay, so this kind of contour you can get, and various output can be replaced. So this is all about the entire profile of how ANSYS fluent problem can be set up. This can be a test problem for you. Okay, so you move. Then I am giving you here some tutorial links. Okay, these are YouTube videos, small videos of 20 minutes, 25 minutes. So if you like to practice, you just see it and step by step you move it. Okay, so that will be helpful for you. So I have clarified all the steps that how to follow, and then these things you can follow and you will be able to do it, I hope. Okay, so one video let me show before you share with you, uh, so that you can understand a little bit for few minutes. Then you can see it. I will share this link in the YouTube, in our WhatsApp group, and you can see it, and then you can try on your own. See, if you do not, unless and until you try your own hand on it, it will not be, you can never learn it. Okay, so you have to practice at least few problems, otherwise it will be not so useful. So let me just once more share the desktop with the audio option. um, what should I show you? Okay, let us see this video for some time. Is it I think visible, but let me confirm I'm getting the sound or not.
Length is 100 millimeter.
Are you getting
The
the
water
sound?
is entering into it at a velocity of 0.00.
Yes, sir.
You are getting right. Okay, so this is again a very problem. Whatever I have explained here step by step, a similar type of thing is represented here, is shown here in the in this video, 24 minutes video. So you can understand the diameter is millimeter, and water is entering into it, and with the velocity of this, and you need to find out the velocity variation in the pipe. The same thing, same problem. Okay, but here it is shown. Let us see sometimes with the description that how they are doing, and you can parallelly either follow the slides that I have shown, or you can follow this video if you have installed it. So let us see for a few minutes what happened.
Sir, is that possible to share the link?
Yes, I will share this link with the WhatsApp in your WhatsApp group. Okay.
Okay, sir.
Okay.
Excuse me, sir.
Yes.
Yes, sir. Actually, are you presenting something? Cause your video presentation has stopped.
No, it is going on. No, I am not. I am just sharing the YouTube video with you. Can you
But
be?
sir,
Are you being able to
Actually, your
see it?
screen is
Follow.
not visible presently, sir.
yes,
No,
sir.
sir.
Sir, your presentation has
Sir, your
stopped,
screen
sir.
is presently not visible, sir.
Oh, that you tell me earlier. Otherwise, how can I?
So right now we can see your
It
screen.
is showing in share. So far you could not see anything. Okay, let me restart it. Now check if you can see the YouTube video here. Are you being able to see it? Visible, audible,
Yes, sir.
everything?
Yes, sir. Visible.
Okay. First step, as I was pointing out, whenever you will open, this window will come up. You just press this fluent option. So this window you will get. Now you just listen to the very lucidly it is being explained here. So all the steps will be clear, whatever I have.
Sir, it is not audible, sir.
Not audible.
No, sir.
Okay, I hope there is a little bit some, maybe due to some network, because it is supposed to work, or streaming may not be proper. Okay, but I am giving the links to you. Okay, giving the links, sharing it with in your WhatsApp group. You open it in your own computer and follow it. This video is exactly whatever I have explained in the last few slides. Okay, and I suggest all of you first you see it and then try to mimic it in your installed versions. Okay, and so that will be good, I think, without following it and sitting it and sharing it, because there is continuity problem. I will share the links, and I will also share 3 more links. This first one is whatever is going on, and second, third is also there, so you can also follow them and practice them. This is for the practice part. So today you may not get much time, but after tomorrow morning class, tomorrow morning will be finite volume method. That mathematical part I will discuss a little bit. Then later getting this read and try to. So that's all. Then we can stop. I think it is a long session. I will share the links. You try these things. Okay, and we'll again meet tomorrow 10 a.m. Okay, so if you have any queries, you can now go ahead. Okay, ask me. Otherwise, I'm going to stop today.
Any of the attendees, if you have any query, you can ask or answer now. He's available at
Yeah,
present in the meeting.
actually, sir, you said that COMSOL works on finite element method, and while ANSYS Fluent works on finite volume method. Sir, is there
Yes, yes.
any kind of problem that might not work in COMSOL? Because I have actually in COMSOL installed my laptop, and ANSYS Fluent somehow I just couldn't download it. So COMSOL,
No. Means what is your question?
like if I download COMSOL, will I be able to do all the chemical engineering problems in COMSOL only, or ANSYS?
Obviously, all the problem. There is nothing called all the problems. Okay, problems can be done in either console and either ANSYS Fluent. Okay, that is not a problem. But both have some advantages and disadvantages. Okay, so finite element has certain advantages, that very complicated geometry you can handle there. Okay, that is an advantage. Uh, just 1 minute, let me take a call. Okay. So as we are discussing that, look, you can set up the problem both finite volume and finite element, anything, that is not a problem, but each has certain advantages and disadvantages. Uh, the advantage of is that ANSYS Fluent has been well established for long time. Okay, it is also tested in industry, academia for a long time, and it is robust. It works. But advantage of COMSOL multiphysics is that it has the multiphysics option. So if you use like to use reaction, different external field, etc., that coupling is easy in COMSOL multiphysics. But again, as a solver, from the perspective of solver efficiency, what I have seen, in some cases convergence issues may appear. Okay, and then you need to work on it, you need to find out the particular reason for it, then you need to solve it. But as a student practice, student project, absolutely no problem, you can use anything. You can use either COMSOL multiphysics or ChESS Fluent, anything, anyone is applicable, no problem.
Hello, sir.
Yes.
Sir, my answers Fluent is downloaded, but it's not opening. It takes more time. What can I do, sir?
What is the means configuration of your system? RAM, processor?
Yes, okay, sir. Can you give me the link of this ANSYS Fluent?
You go to just Google type the ANSYS Fluent
Yes, sir.
student version free download. You go to their ANSYS website and download it.
It's
No problem.
downloaded, but it's not opening. Much more time. It takes 3 hours. I'm doing, but it's not opening.
If your computer processor is little bit old, i3 or earlier version, then it may have some problem. I heard it. Okay, if you have i5 and 8 GB RAM,
Yes, sir.
it
It's
should
my
it should
i5 answer.
i5 and 8 GB RAM should work.
Yes, sir.
Okay,
It's my computer center. But how? But it's not working.
it is a problem of your computer, means your software installation, maybe some supporting file it is not getting, that may be the issue, means your installation is not proper, your OS installation is not okay, that may be a cause,
It's
because I
showing,
have
sir.
tested it in my computer and in lot of other students computer, mostly it works. Okay.
Request resource will be granted from Linux server. Showing, sir.
Linux server, Linux, are you downloading the Windows version or Linux version?
Linux version.
No, probably you are downloading the wrong thing. It can be downloaded either in Windows or Linux. So if you try to install the Linux version in Windows, it is not going to work.
Oh,
That you check.
yes, sir. It's Linux version.
Then how it will work on Windows?
Yes, sir.
Okay, so that is the problem. Anyone else? Okay, if no questions, then we can close today's session. We'll meet again tomorrow, 10 a.m. Okay, thank you all.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you all. Thank you.
Thank you, sir.
We will meet again tomorrow at 10 a.m. Thanking you for your attendance and your time.